G index. G is the so-called stagnant conditions, which is used for horizons affected by wetness. The main idea is that this suffix tells us that the horizon has experienced, the soil experienced conditions of water saturation long enough to limit the oxygen in the soil. When soils become saturated with water, oxygen in the pores is depleted. Under these conditions, the iron in the soil gets reduced and becomes mobile. When the soil dries and the oxygen returns, that iron reoxidides and forms reddish mottles or concentrations in the soil. This is why horizons with the suffix G show grayish colors along the root channels and reddish mottling far from the root channels. L index. Again, this is very similar to the G index because both indicate glaciation or glaying. But usually when we have the G index in the soil, that indicates water stagnation. This is the result of water stagnation. So the G index, this color pattern that we can see here, is the result of water stagnation, which means that the excess water that is responsible for the development of this color patterns comes from the surface in the form of very heavy rainfall, comes from flood water, and in the soil there is a water restricting layer that does not let the water flow downward. So the water stagnates. So the excess water comes from the surface. But in case of the L index, the groundwater is the source of the excess water. And the groundwater is responsible for the development of this color pattern. So the water rises from below, not from above. And the field indicators of this groundwater caused glaciation, grayish matrix and small reddish mottling near the groundwater zone. And usually it develops near the lower parts of the soil profile. Air index, which means strong reduction. This means very low oxygen conditions, prolonged water saturation, strongly reduced matrix, which comes in the form of grayish, bluish, or dark reduced colors, often associated with groundwater influence or permanent wetness. In meadow soils, in so-called clay soils, usually horizons below the groundwater level are strongly reduced and they have grayish, bluish, so-called reduced colors. Age index. Age index is the alluvial accumulation of organic matter. Typical characteristics of the age indices is having a dark subsurface horizon, as you can see here. This is a very special phenomenon. This develops only in very acidic conditions. In very acidic conditions, the organic matter in the topsoil can go into solution. Organic matter can be mobilized in the topsoil and moves downward from the upper horizons and accumulates in lower horizons. In normal conditions, this does not happen. But in a very sandy material, in case of extreme acidity, this can happen. And in the so-called podzol soils, this is the typical subsurface accumulation of organic matter that we indicate as the so-called age, VH horizons. SS index indicate silica size. Silica sides are shiny, polished surfaces appearing mostly in shrinking and swelling clay-rich soils. When the soil contains shrinking and swelling clays, and the horizon has been affected by internal soil movement, that means when these kind of soils get wet, they change volume, they expand, and when they get dry, they shrink, and this repeated shrinking, swelling causes very special kind of shearing forces in the soil, leading to the development of large cracks and to the development of these shiny pressure faces that we call as silica sites that you can see here. N index. N means the pedogenetic accumulation of exchangeable sodium. Sodium, if we have a lot of sodium in the soil, and in Liberia, most probably this can happen only, may happen only close to the sea, in coastal areas, then we can have a lot of sodium. The accumulation of sodium in the soil has a very high effect in the soil conditions. In this case, pH of these soils can be very high, and the chemical properties of the sodium may lead to the development of a very dense and very hard topsoil or subsoil layer, which restricts the infiltration and rooting. And as I mentioned, this is mostly relevant in coastal and marine influenced settings. P index. P means plowing or other human disturbances. Usually when we see any kind of human disturbance, any kind of tillage in the topsoil, we indicate as by adding the P index next to the A master horizon. S index. S index means the alluvial accumulation of so-called sesquioxides. Typical characteristics, so basically the sesquioxides are developed under very acidic conditions. They are iron and aluminum compounds in the soil, and the alluvial accumulation of sesquioxide, their typical characteristics is that we see reddish, brownish layers deep in the soil, so in the subsoil, usually in the B horizons. This is usually associated with leaching from the upper horizons, and usually they go together with the age index. So in the so-called podzol soils, in very sandy materials, under very acidic environment and very acidic conditions, the mobilization of the organic matter together with these aluminum and iron compounds, they form a very characteristic BHS horizon in the soil. O index, residual accumulation of sesquioxides. So previously we saw the alluvial accumulation of sesquioxides. In case of O, this means the residual accumulation of sesquioxide. Alluvial always means that a material that has been here before gets alluviated, gets washed down into the subsoil from the topsoil. This is very briefly the so-called alluviation. Residual accumulation means that these materials form in situ, in place. They don't move, they stay there. So if we don't see such very characteristic horizonation in the soil. But the soil is very red, which means the enrichment by iron and aluminium oxides. And it is strong red-brown, yellowish-brown, but we cannot see that these materials moved downward in the soil. That means the residual accumulation of sesqui oxides in the soil. This is usually the result of intense weathering and the accumulation, enrichment in iron and aluminium oxides. T index. This is the alluvial accumulation of the clay minerals in the soil. The very important evidence and characteristic evidence of having clay accumulation in the soil, that the clay content increases with the depth. Usually it is a gradual or sometimes an abrupt change in the clay content. So this is responsible for the development of clay-enriched subsoils. W index. W index means that in the subsoil, pedogenetic development, color development, structure development has been ongoing, but without the clear evidence of specific soil forming process. So if we see in a soil profile that some kind of soil forming process is ongoing, but we don't see clay illuviation, but we don't see podzolization, we don't see the evidence of any kind of strong soil forming process, that is, those are those horizons that we indicate, that we call as the W weak horizons. And I think almost the last index that we discussed today is the accumulation of salts in the soil. Usually these are characteristic to dryland areas. In Liberia, they are mostly relevant in coastal lowlands, estuaries, tidal flats, and mangrove zones. They are not expected to be widespread inland, so this is the accumulation of different kinds of salts in the soil. And the last one, which is very important in Liberia, this is the occurrence of plintite and the M index together. Why are they important? The V index indicates the presence of the plintite, which is an iron-rich and often also manganese-rich material in the soil. It's humus-poor mixture of quartz, clay, and mostly iron oxides. Usually it is soft when it is moist, but if we let it dry out, usually it hardens irreversibly when exposed. Typical indicators of plintite-rich horizons are the red mottles or nodules, irregular iron-rich aggregates, or zones that may harden over time. And the M index means massive, strong cementation, means the material is already hardened. Usually M indexes are hard pans in the soil, which strongly restrict root and water movement in the soil. And for example, on this picture, if you see that we have a BV horizon, this means that in the upper part we have plintite, and the lower part we have plintite, which is strongly cemented, for example, petroplintite.